Alright, so chapter 14, we're going to be talking about counting and probability. So the first thing before we get to probability, which is going to be 14.3, we're going to talk about different ways you can count items, or the total ways something can be arranged, to say. So the first thing we need to know is something called the fundamental counting principle. Now, the fundamental counting principle is used when you have multiple choices given with multiple ways of doing each. So, to kind of break this down in a different term, basically, let's consider an example where you have ties, coats, and shirts, and you want to figure out how many different outfits you have. Well, think about it this way. If I have, let's go with 3 ties, 2 coats, and 6 shirts. So if I pick coat number 1, I can arrange that with tie 1, tie 2, tie 3. And then that tie can be paired with 6 different shirts. Well, think about keeping on going and doing that with each one. It's a lot of options to do. There's an easier way to do that. So if this example happens, we're going to take the choices and we're going to branch them out. We're going to do the number considered for option 1. We're going to multiply it by the number for the next option. And in this case, since we have 3, we're going to multiply it by the number for the option 3. 2 there. And if you have more options, you can keep going. Or you can do less. So basically, you take the number of choices and you split them up. So for this example, we would do 3 times 2 times 6. So 3 times 2 times 6, 6 times 6, there's 36 different outfits. Alright, so let's turn that into some word problems here. This chapter is very heavy on word problems, so you have to be very careful about how you read the problem. So, to go to Chicago, from Chicago to Oak Park, there are 6 different ways you can take. Now, to get from Oak Park to Roselle, there are 3 different ways you can take. So the question is, how many different ways are there to go from Chicago to Roselle? Well, we're going to take Chicago to Oak Park, and we're going to multiply it by Oak Park to Roselle. So we're going to take 3 different ways, we're going to multiply by our 6 different ways to get a total of 18 ways to go from Chicago to Roselle. Alright, so now let's consider the next thing. At Taco Bell, each Taco Supreme can have a soft shell, hard shell. So soft shell and hard shell, those 2 things kind of go together. So that's 2 options there. Sour cream, lettuce, cheese, and tomatoes. We know how many different ways can you have the Taco Supreme. Well, if we're building things, like a sandwich or a salad or tacos, consider include and not include. So let's think about this. We have the shell. We have two options for the shell. We can have sour cream or no sour cream, because not everybody likes sour cream. We can have lettuce or none lettuce. So that's two options. We can have cheese or no cheese. And we can have tomatoes or no tomatoes. So altogether, we've got 2 times 2 times 2 times 2 times 2. So we have how many different ways to make a taco? We've got 32 different ways. 32 different taco supremes. Alright, moving on. We've got how many different license plates are possible if each plate consists of 4 letters and just one 3-digit number. The key information here is assume repetition of letters and or numbers is allowed. And we can use any of the 2-digit numbers or 10-digit numbers. So 10 digits, that's just saying 0 through 9. So if you ever see 0 through 9, that's actually 10 digits. So 4 letters, we need 1, 2, 3, 4. So this is a letter, 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 another letter, and then we have a number. So how many letters are there in the alphabet? Hopefully we know that there's 26. So I have 26 options, 26 more, 26 more, and 26 more. Multiplied by how many options are there for digits? There's 10. So what do I get in the end from this? Oh, by a 3-digit number. My bad. I need another number and another number. So how many total options do I have then? If we multiply that all together, gonna need the calculator for this one. 26 times 26 times 26. And just be careful about how many times you've entered things. So we have a huge number of license plates that are possible. 456,976,000 license plates. Alright, so now let's talk about one more option, and then I'm going to have you guys try this last one on your own. So this one is going to end up being a you try, but for those of you who may not know decks of cards, we're going to talk a little bit about decks of cards here. So a poker hand consists of 5 cards drawn from a deck of 52. And we need how many different poker hands consist of an ace, 2, 3, 4, and 5. So we need to know how many of each of these there are in a deck. Well, there are 4 aces, 4 twos, 4 threes, 4 fours, and 4 fives. It's 4 of every single individual card, 13 of each suit, 26 of each color. Those are some key things that we're going to talk about in this unit. Alright, so I want a 5-card hand, and I need those options. Well, 1, 2, 3, 4, 5. 5 cards. So slot 1, 2, 3, 4. That's your hand. We know 4 aces, 4 twos, 4 threes, 4 fours, and 4 fives. Multiply them all together, and we get 1,024 hands. Alright, so kind of similar thing for number 5 for you to do on your own. Alright, so now let's talk about something a little bit different. Let's go backwards with the fundamental accounting principle. So they gave us the amount. So they gave us the total, 2,048 different ways of pizza. The number was attained by using the fundamental accounting principle in order to include or one of each of several toppings. We need to know how many toppings were used to get that. Well, let's think about this. So include each of several different toppings. So you can include or not include. So that's two options. So it's 2 times 2 times 2 times 2 times 2 to get this number eventually. So working backwards, we know we need 2 to some power equals the total here, 2,048. Well, it looks like we're stuck in an exponential equation. Well, remember back to chapter 11, where we had the base raised to an exponent equals the answer. So the base of the exponent equals x. So let's try that. Base, so log base 2 of 2048 equals your exponent. Now, some of your calculators can do this offhand, but not every single one can. So remember that we need to sometimes do change of base. So what does this become? It becomes log of 2048 over log of 2. So again, in your calculator there, you're going to do log. You're going to use the log button all the way down there. 2048 and dividing by log of 2. And it gives us 11. So there are 11 different toppings. And that's how you would work backwards with the fundamental accounting principle if you're given the options. Alright, let's talk about something called a factorial. A factorial is denoted by an exclamation point and it comes after a number. So an example is 10 exclamation point. And no, it is not just excited math, although I like to think of it that way. So it means, what does it mean? It means multiply by a series of descending numbers starting with the number next to the exclamation point. So for example, we have 6 factorial. So start with 6 and then we're going to descend 5, 4, 3, 2, 1. So 6 times 5, 30 times 4, we get 120, 120 times 3, we get 360 times 2, 720 times 1 is still 720. Now, of course, you can use your calculator for that. Well, 1 factorial, that's really easy. 1 times 1, which is just 1. Now, the one that's kind of tricky is 0 factorial. 0 factorial is actually also 1. So that one is just 1 that there's the rule that it equals 1. Alright, what about multiplying factorials? You just use both factorials. So 2 factorial is 2 times 1. So that's 2 factorial. 4 factorial is 4 times 3 times 2 times 1. So what does that equal? We'll multiply it all out. 2 times 4 is 8, times 3 is 24, times 2 gives us 48. Alright, this one is for you to try. And let's move on to dividing. Well, dividing, again, just expand. So expand your factorials first. The top is 5 times 4 times 3 times 2 times 1. Well, what about the bottom? 3 times 2 times 1. Well, what do you notice here? You have some in common. The 1s, the 2s, and the 3s. So what can you do with them? You can get rid of them. They're going to divide out anyway. So 5 times 4, which is just 20. Now, of course, it is always important to know how to do these by hand, but we can also use the graphing calculator by going math. So first, you're going to go to math, arrow over to probability, and then there's an exclamation point, and you go that. So let me show you how you would do a problem like example 8. Well, I need to put the 8 in first. Now I'm going to go to math. I'm going to arrow over all the way to probability, so up there, and I'm going to use the factorial, times 7 factorial. So math, arrow over, factorial. Right? And we get a huge number. So this is where you might want to use it because you get a really big number. Right? So put some commas in there. There we go. Same thing with dividing. Now, when you have multiple on the bottom, you're going to want to use parentheses. In this case, I don't have to. But if there are multiple in the denominator, make sure that you put parentheses around it. So 12 and factorial. 2,730. Oops. Now you could have done this one by hand also. 15 times 14 times 13 times 12. But realize that 12 times 11 times 10 dot 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 times 12, 11 times 10 dot dot dot, they start canceling out. So all you would have to do is do 15 times 14 times 13 to get there. Alrighty, so that is the first part of chapter 14, and we're going to learn some more accounting and principles in the next video.